Question today says, why is a minimum wastewater force main velocity commonly maintained? Is it A, to maximize dissolved oxygen throughout the entire force main? Is it B, to scour the pipe and limit internal solids deposition? Is it C, to force the connected motor to operate at higher speeds? Is it D, to prevent pipe failure caused by low internal pressure? So let's look at the answers. So to maximize dissolved oxygen throughout the entire force main, no. While it does create turbulence, introducing air into it, that is not why we do it. Is it B, to scour the pipe and limit internal solids deposition? Yes. So the scouring rate in your conveyance systems is generally, the rule is generally at or around 2 feet per second. So 2 feet per second. That's going to lift the solids and not allow them to deposit. So B is looking good. Is it to force the connected motor to operate at higher speeds? No. If you're going to operate the motor at higher speeds, then you're probably going to kill the motor after a while. So that's not the answer. Or is it to prevent pipe failure caused by low internal pressure? And that is not the case. So the answer is going to be B. All right, next it says number 2. It says, which mineral scale contains magnesium, ammonium, and phosphate? Is it ferric? Phosphate? No. Is it struvite? Yes, struvite has ammonium, and it has well, is this not writing? Is it vivianite? No. Or is it calcium carbonate? No, calcium carbonate is how alkalinity is measured. So alkalinity is generally good in wastewater, so and it doesn't typically scale. So no, it's struvite. Number 3. An operator hears a sound like jumping marbles or clattering rocks from a centrifugal pump. What is the most likely case? Is it A, incorrect or reverse rotation of the pump? No, that wouldn't cause any clattering. Is it dry or failing bearings in the motor? No. Why is this not? No. Is it B, a loose or damaged pump impeller? No. Is it D, cavitation occurring inside the pump casing? Yes. So when you have air in your lines and you have cavitation, those air bubbles are going to collapse. They're going to explode, and then they're going to start tearing apart your pump, sounding like clattering rocks. Sounds like it's just really loud. Next, before starting a centrifugal pump located above the water source, what must usually be done? Is it A, prime the suction line and casing up the liquid? Yes. If you have a centrifugal pump, it's going to be need to be primed because it's above the water source. If you have air in there, it's just airbound. It's not going to be pulling anything. So is it B, increase the motor overloaded settings above normal? No. Is it C, close every valve connected to the pump? No. Is it D, open only the air valve on the discharge? No. All right, number 5. How is biologically stored phosphorus ultimately removed from an EBPR system? So phosphorus is removed when you're talking about EBPR. Let's see, in an A2O system, you're going to have your anaerobic tank, your anoxic tank, oxic, and then your aerobic or your oxic tank. Phosphate is going to come into here. The PAOs are going to drop it off. It's going to pick up a VFA, and then it's going to take it here. You're going to create PHAs. pH Bs, and then eventually you're going to pick up the polyphosphate. So polyphosphate, and that's going to uh, make your PAOs heavy. It's going to sink down, and then it's going to be removed from your through wasting. So let's look at the question again. How is biologically stored phosphorus ultimately removed from an EBPR system? Scale deposited on anaxic walls? No. By wasting? Yes, I just said that. A phosphorus-rich biological biomass? Yes. Is it phosphine gas released from treatment? The only gas to release over here that we care about is going to be your nitrogen gas through denitrification, or as scum collected from anaerobic zones. No, no scum is collected from your anaerobic zones, generally at least. What is likely? What is the likely consequence if velocity in grit removal channel falls below its designed target? So, if what it's saying is if you have a grit channel, and let's just say velocity is too slow. Well, sorry. If you have a grit channel and you have a primary clarifier right there, um, your grit is going to settle out in your grit channel, and then your solids, your primary solids, are going to settle out in your primary clarifier. But if it is too fast, then these solids are going to go here. Your grit's going to go there. If it's too slow, your primary solids are going to settle out there. So let's see. What is the likely consequence if velocity in a grit removal channel falls significantly below its design target, meaning that it's so slow that these solids don't make it to your primary. So these solids are just going to stay here. They're never going to make it to your primaries. So greater abrasive wear during because more grit carries? No. More removal of dissolved salts from the flow? No. All grit passes directly into primary clarification? No. Or is it D, organic solids settle with grit and become septic? Yes, that is the answer. You'll also start noticing that you'll have H or number 7. What happens when volatile fatty acids rise rapidly without a corresponding increase in alkalinity? Is it A, digester pH rises while overall methane production remains stable? No. Is it methane production increases while overall digester pH remains stable? No. Is it C, buffer is consumed, pH falls, methanogenesis becomes inhibited? The answer would be C. So buffer is consumed, right? If volatile fatty acids rise, so acids are rising without corresponding alkalinity. Alkalinity is the buffer, that calcium carbonate, measured in calcium carbonate. If that's rising and you're not increasing alkalinity, then you're going to consume your buffer. And again, it's acidic, so the pH is going to fall. If it's too acidic, then methanogenesis, the last step in anaerobic digestion, becomes inhibited. All right, number 8. If pump suction lift is too high and the suction line is restricted, what condition is likely to develop? Is it so? What's basically happening is that you have a pipe and it's sucking very high, right? So this is the bottom of the pipe right here, and then you're gonna have air bubbles. But because it's going higher right here and it's restricted, there's going to cause the air bubbles to expand. So what condition is likely to develop? Is it A, increased pump efficiency? No. Is it B, automatic speed increase? No. Is it C, excessive pump packing leakage? No. The answer is going to be cavitation. Cavitation happens when you have a negative suction or a high negative suction, pulling the molecules apart, that air bubbles that were small because of the pressure are now bigger because of the decreased pressure. So pump cavitation. Which trend most directly warns that acid production is outrunning methanogenesis? Is it A, declining grit concentration in the digester sludge? No. Is it B, increasing dissolved oxygen in the oncoming sludge? No. Is it C, falling feed total suspended solids without other changes? No. Is it D, rising volatile acids relative to available digester alkalinity? Again, if you have high acid production, that means you're probably feeding too much because acid production is happens earlier on. That means that there's going to be more food available. You think about like your stomach. Once you have food available, your stomach will produce acids to break down those foods. So yeah, and if the rising volatile acids relative to available alkalinity. So D. All right. A standard centrifugal principle curve shows a relationship between, you don't need to know that for almost any test. All right. Which conditions are required for anaerobic zone to select effectively for polyphosphate accumulating organisms? So you have three zones. You have, again, you have your anaerobic, anoxic, and aerobic. Your anaerobic zone is going to have no DO, no nitrates, nitrites, 2, 3, or any dissolved oxygen. This is going to have nitrates, nitrites, and then this is going to have DO. It's going to recirc, and that's going to give the NO3 and O2s, and that's how you're going to have your combined oxygen. But we're talking about the anaerobic zone, which has no DO, no nitrites, nitrites and nitrates. So, what condition is required for in the anaerobic zone to select effectively for polyphosphate accumulating organisms? Is it A, continuous aeration with measurable dissolved oxygen presence? No. The absence of both oxygen and nitrate? Yes. Good. So the answer is B. If a bar screen becomes blinded and is not cleaned, what is the most immediate operational problem? So if you have a bar screen and it gets blinded, that means the flow that's going to come through is going to stop up. If it stops up, then it's going to overflow. But anyways, let's look at the questions. Let's look at the answers. Is it downstream BOD removal immediately doubles in efficiency? No. Is it grit chamber velocity automatically increases above its design value? No, because if less water is going to your grit tank, then like that's it's going to actually decrease. So no. Is it anaerobic digester methane production immediately stops throughout the whole process? Anaerobic digester methane production has to deal with how much solids are coming from your primary and your secondary, so that is not true. Or is it upstream water level rises and may overflow or bypass? It's D. That's D. All right. So, which environmental condition supports denitrification in the anoxic zone? Again, look at the table I gave you earlier. You have your first one that's your anaerobic, anoxic, and then you have your aerobic. So, your anoxic zone is going to have your nitrates in it. So, let's see. Is it complete absence of dissolved oxygen and nitrate? No, because your anoxic zone has nitrate. Is it strongly acidic conditions with pH below 5? No, that's going to inhibit your it's just going to inhibit denitrification after if it gets too low. Is it very low DO with nitrate readily available? Yes. So if you have you still have DO in your anoxic, it's just really low and it's inhibited after it reaches above zero point 0.3 milligrams per liter of DO. All right, what normally happens to pH when ferric chloride is added for chemical phosphorus removal? So let's see. For number 14, is it A, it rises sharply because additional alkalinity is produced? No. Is it decreases because acidity and precipitation consumes available alkalinity? Yes. You add ferric chloride, it combines with your calcium carbonate, and it's going to become acidic. So, and your acid scale is from 0 to 14. Neutral is around 7. So if you're going acidic, you're going down. If it's basic, it's going up. All right, so it's B. All right, what type of pump is commonly used to meter precise quantities of polymer or ferric chloride? Is it well, I guess the answer is going to be positive displacement metering pump, but it's in the toxic inhibition, no, and eliminates the need for separate anoxic, no. Usually in the wintertime, because water gets colder, you're going to have to actually uh, increase the detention time by increasing the amount of cells you have or the amount of tanks in service. Okay, next, during the anaerobic phase of enhanced biological phosphorus removal, what do PAs generally do? PAOs generally do. They in the anaerobic phase. So, is it take up phosphate while releasing VFAs? No, that's actually the opposite. Is it consume nitrogen gas while producing soluble organic carbon? No. Is it release phosphate while taking up VFAs? Yes. You can release the phosphate, you're going to take up the VFAs, you're going to create the ATP for extra energy. All right, next. Which device shreds large debris without removing it from the wastewater flow? It's going to be a comminutor. A comminutor is just like a garbage disposal. Think about the garbage disposal in your kitchen. It'll shred your waste, but it's not going to take it out of it. Is it a partial flume? No, that's to measure flow. Is it a partial stream? No, or grit classifier? No. All right, what is the primary purpose of preliminary treatment in wastewater treatment plant? Is it A, to protect equipment and improve downstream process efficiencies? Is it B, to settle and remove? Is it C, to remove dissolved organic matter from biological oxidation? Or is it D, to achieve significant reduction? And it's going to be A. All right, which organisms compete with PAOs for volatile fatty acids without providing luxury phosphorus uptake? Is it nitrite oxidizers? No. Is it sulfur filaments? No. Is it glycogen accumulating organisms? That is the answer. GAOs take up VFAs, which is an energy source, and then but they do not provide luxury uptake phosphorus, so they're taking the food of the PAOs, which is not great. All right, next, what is the typical methane content of raw biogas from a stable municipal anaerobic digester? Is it 85 to 95? Is it 30 to 40? Is it 10 to 20? Or is it 60 to 70? And the answer is D, 60 to 70%. The higher the content, the bluer the gas. Once you start getting lower content and you start getting a lot more carbon dioxide, then you'll start getting yellow gas, which is dirty gas. All right, next, what material is specifically targeted for removal during grit? Is it dense inorganic particles such as sand and gravel? Yes, grit is just sand, gravel, concrete from uh, wearing away from H2S. All right, so an operator observes rising sludge and small gas bubbles in the secondary clarifier blanket. What is the likely biological cause? So you have a clarifier. For some reason, you have gas bubbles in your clarifier, and then it attaches to the sludge and it just rises, right? So what's happening is that you're having denitrification occurring here. So is it A, excessive aeration? No. Is it B, emulsification? No. Is it C, immediate inhibition? No. Or is it D, denitrification occurring in the clarifier? Yes. So your sludge is getting septic, basically. All right. What is a major operational consequence of nitrite accumulation before chlorination? So is it IMLR, internal mixed liquor, recycle pumps stop mechanically? No. Is it nitrogen can no longer form? No. Is it nitrite creates a large chlorine demand? Yes. You're going to have a lot of chloramines be generated because of this. All right. So next, which microbial group converts propionic acid, butyric acid, and similar intermediates toward acetate and hydrogen? All right. So um, like you should know this stuff right here, but what's really important is right here. It says it converts to acetate. So it's generating acetate. So is it A, acetogenic bacteria? Yes, because it's generating acetic acid. Is it B, methanogens? No, because it's not generating methane. Is it nitrifiers? No. Is it PAOs? No. So the answer is acetogenic bacteria.